Hello everyone, welcome back to Max's Math, where today we're going to be looking at quiz 2 for calculus 3. Getting started here, we have problem 1. Select the statement that must be true, select all that apply. First one here, the lines given by L1, x minus 1 over 3 is equal to y plus 5 over negative 4 is equal to z minus 2, and L2, x plus 17 over negative 6 is equal to y minus 23 over 8 equals z plus 34 over negative 2 are parallel. Now, to check if a line is parallel, there's two methods we could use. The first one is the cross product between two parallel lines is equal to 0. Or if we look at their the vector notation for the lines, where it's in this form, one would be a common multiple of the other, meaning that we can multiply this one by a whole number x and it'd be equal to this one. Now, this method for me is significantly easier, so we'll be using this method. To find the vector direction of these lines, it's quite simple. These are written in a form such that all of this here is equal to t. Now, down here, over here is the directions of the lines, these little things. This is over 1. Over here is where they start. So if you want to get this to a more familiar version of a line, if we start with this one here just for an example, we would multiply the 3 over, so this is 3t, then add 1. And if you recognize, that's a much more familiar equation for a line where x is equal to t times 3 plus 1. So the vector notation for this line is quite simple to find. We just have to look at the denominator in each one of these. First one is 3, second one is negative 4, last one is 1. Now, to find the vector notation for these lines is quite simple too. Negative 6, 8, negative 2. Now, the question is, can we multiply this vector by something so that it equals this vector? And the answer, if you're looking at the pattern here, is yes. If we multiply this vector here by negative 2, it will equal this vector. Negative 2 times 3, negative 6. Negative 2 times negative 4, 8. Negative 2 times 1, negative 2. So these are parallel. So that makes this one true. The vector 1, 1, negative 2 is orthogonal to the plane 2x minus 2y plus 4z is equal to 8. Now, this one is a little bit tricky because we have to find orthogonal between a vector and a plane. However, the way you go about this is firstly to recall what it means for two vectors to be orthogonal, that the dot product between the two vectors, v1 dotted with v2, is equal to 0. Now, the first vector here is given 1, 1, negative 2. And the second vector, well, it doesn't give us a vector, it gives us a plane. But if we recall in the equation of the plane, the coefficients next to the variables is going to be the vector direction of the normal vector to the plane. Or if you're unfamiliar with it, a plane looks like a sheet of paper in a three-dimensional space. It has a normal vector given by the coefficients here, so that this vector here is going to be perpendicular to any spot on this plane. So we have a vector and a plane, and we have a line here that is orthogonal to the plane. So if we want to figure out if the vector is orthogonal to the plane, it must be parallel to the plane's orthogonal vector. So we actually have to check for parallelativity, not orthogonality. Now, to figure this out, as stated above here, we have two separate ways. The second method, which I think is significantly easier, is there any number we can multiply this to get this by? And it might seem that we might be able to multiply it by 2 or negative 2 to get it, but if you're paying close attention to the negative signs here and here, it's quick to realize that we can't multiply it, because if we multiply it by 2, then this one would be negative 4, that's positive 4. If we multiply by negative 2, this one would be 4 and 4, that checks out. Over here, negative 2, that checks out. Over here, this would be negative 2, that's 2, so that wouldn't check out. So these The vector and the plane are not orthogonal, making that one non-true. Taking a look at C here. The distance from a point P, where P is given here by PQR, to the plane ax plus by plus cz is equal to 0, which passes through the origin, is given by the expression distance is equal to a squared plus b squared plus c squared over pa plus qb plus rc. Now, just check if this one's true. Let's recall the equation for the distance between a point and a plane, where distance is equal to the magnitude of qp dotted with n. N is the normal vector of the plane, and q is a point on that plane, while p is the point you're trying to find the distance of, divided by the magnitude of n. Now, if we're taking a quick look at this, you'll notice that these equations don't match up. A simple fact of that is, if we were to find the magnitude of n here, which is this one here, we would have to find first n, which is going to be a, b, c. So here's n. To find the magnitude of it, we're going to do a squared plus b squared plus c squared, and then if I take the square root. So that should be in our denominator. However, this messes in our denominator, making this equation mumbo jumbo, which that is a mathematical term. Taking a look at D here, the planes x plus y minus z is equal to 0, and x plus 2y plus 3z are equal to 6 are orthogonal. To check for if two vectors are orthogonal, recall over here, where the two vectors, the dot product must equal 0. So if we were to write these in vector form here, we have 1, comma, 1, comma, negative 1. That's just taking the number in front of the x, y, and z components, dotted with 1, comma, 2, comma, 3. 1 times 1 is 1, plus 1 times 2 is 2, plus negative 3 times 3, which is negative 3. 1 plus 2 is 3, minus 3 is equal to 0. So these are orthogonal. That checks out. Looking at the next one over here, that the limit of t goes to 2 of rt minus u over t minus 2 is equal to 12i minus 10j, where u is equal to 8 comma negative 10, and rt is a continuous vector valued function. Find the value of the derivative of tangent of pi over t over 8 times r of t at t is equal to 2. Now, this question may seem very complicated, which it is. However, once you understand what's going on here, it makes it a lot easier to figure out. First things first, let's evaluate what we can evaluate from this derivative here. Where, if we were to write it, d over dt of tangent of pi t over 8 r of t at t is equal to 2. Now, to take this derivative, it's going to be a chain rule that we're going to have to do, as well as the quotient rule. Or, is it quotient rule? Multiplication rule, one of them. Quotient's division, multiplication rule, it's the, I forget the name. But follow me along for the logic. Take the derivative here. First one we have to do is this one, which the derivative of that comes out to, derivative of tangent is secant squared times pi t over 8, and then derivative of the inside, pi t over 8, is just going to be pi over 8 times r of t, plus here's where the multiplication rule comes in. We take this one, tangent of pi t over 8, times derivative of this one, which we don't know what this one is yet, so we'll just call it r prime of t. Now recall, this is all happening at t is equal to 2. So if we're plugging 2 for t in all these places, we get pi over 8 equal to secant squared of pi times 2 over 8, which is just going to be pi over 4, doing a little simplification there, r of 2, plus the tangent of, once again, plug in 2 here, it comes out to pi over 4, r prime of 2. Now, we got some nice little numbers here. However, it seems like we're stuck. We don't know what r of 2 is and r prime of 2 is. However, recall the information that it gives us up here. If this equation here looks vaguely familiar to you, that is for a reason. This here is the limit definition of a derivative, where this is the answer of this is the derivative of r of t at 2, and u is equal to r of 2. The more familiar way you might have seen it would be f of x minus f of x plus t over t, limit as t goes to 0. That's the limit definition of a derivative, which we're drawing upon for this one. So, using that knowledge, r of 2 is just going to be equal to u, which u is equal to 8, 10. And r prime of 2 is equal to the answer of this, which is 12i minus 10j, which, if you recall our ijk rules, this can be written as 12, negative 10. Knowing this, we could plug that information down to here. The secant squared of pi over 4 is, if we recall our radian circle, which I don't at the moment, you'll be able to solve that quite easily. However, we could figure it out with the logic. The secant squared is the inverse of cosine. Cosine of pi over 4 is root 2 over 2. So we flip that around. We get 2 over root 2. We square that. We get here. We get 4 over 2. So secant squared is just 2. Secant squared of pi over 4 is just 2 times pi over 8. So it's going to be 2 pi over 8. Cross that out. This comes pi over 4. So this is pi over 4 times r2, which our r2 here is going to be 8, 10, plus the tangent of pi over 4, which is just going to be 1, times r prime of 2, which is that. So it's going to be 1 times this, which is this. No. Doing some math here to multiply everything out, and I'll bring this all up here just to rewrite. Give myself a little more space. Over 4 times a vector 8, 10 plus 12, negative 10. You can see there. The distributing this out, we get 8 pi over 4, which just comes out to 2 pi. Then 10 pi over 4 plus 12, negative 10. We're doing a little bit of adding here. 2 pi plus 12, which is just going to be 12 plus 2 pi, comma, 10 pi over 4 plus negative 10, so it's just going to be, what is that? Which I've made a little mistake here. I forgot to carry over this negative here from u. I forgot to write it there, so this becomes negative. This also becomes negative here, and then this also becomes negative over here. Now, if we look over here, none of our answers look like that. However, that does not mean that we're wrong. These answers over here look kind of similar. They just rationalized this part of the equation here a little bit differently. And with a little bit of rewriting, we could see how this answer is the correct one, because if we rewrite this one here, just switching the 2 pi and 12 around. So we got 2 pi plus 12, comma. What they did here was they wanted everything under that 4, so they multiplied this by 4. So it's going to be negative 10 pi minus 40 over 4. And you can see if you simplify that out, divide by 4, it's negative 10. So all it works perfectly. So our answer is B. And checking the answer key, we have AD, 2 is B. Number 1, AD. Number 2 is B. So that works perfectly. Thank you for watching. See you guys next time.